All right, section 7.2 is series. So what is series? Series is the sum of the numbers in a sequence. Add all the numbers in a sequence together, we have the series, we have the sum. A finite series is where we're adding finite values of a sequence. In other words, it ends. We have a specific number of numbers in our sequence that we're adding together. An infinite sequence can only be done with a specific type of sequence, with geometric sequences that get smaller and smaller and smaller and smaller. So we literally can add infinite values of a sequence together and get a sum, because eventually the numbers we're adding get so small that it's like we're adding nothing. So we've ended up at a number. So we will get to that in a few minutes. We need to start understanding summation notation. I don't know if you've seen summation notation before. This thing here that looks sort of like a backwards 3, or maybe an E, is actually a Greek letter. It's the capital letter sigma. You might have seen it before in a spreadsheet program like Excel or Google Sheets or something like that. And it's typically the symbol we use. We click on that button in that program to add a bunch of numbers together. So I think it's the Greek letter sigma because they're kind of saying it's S for sum, but it's just traditionally used in math to indicate the sum. Okay, and then the other little numbers on it are what we call index numbers. So the bottom index number tells us where to start, and the top number tells us where to end. So you can see this sequence here would come from taking our sequence, a sub n, and adding the numbers in the sequence, starting with number j and ending with the term number p. So for a finite sequence, that tells us where to start and end. For an infinite sequence, we put an infinity on the top, and that means we start at this first number, but then we keep adding the values forever. Okay, so some of the stuff I just explained is written out right here for you. So if you forgot, Greek letter sigma, summation, has an index, it's got a lower limit and an upper limit that tells us where to start and end. Okay, I still see some of you writing, so I'll give you a little more time. Again, we are going to find the following sums. They're not too big, so they won't be too bad. This first one, we are using this definition for our sequence, so 3n minus 5. We're starting at 2, and we're ending at 6. So let's go ahead and find, so that means we're going to be adding a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6, right? We start at 2, end at 6. And to find each of those numbers, we're going to have to plug them into that little formula. So we have 3 times 2 minus 5, so that's 1. And then, let me change the color and go a little smaller. And then we'll have 3 times 3 minus 5. So that would be 9 minus 5, which is 4. And if you notice, this is actually a formula we talked about earlier, isn't it? Yeah. I think this is the one we saw earlier on that example we were doing. So this is adding 3 each time. It's not the same one, it's similar. It's adding 3 each time. So instead of actually having to keep plugging in the numbers, once we see, oh, this is arithmetic, it's adding 3 each time, just go with it. So 7, 10, 13. Make sure I've got 6 numbers. 1, 2, 3, 4. Actually, 5 numbers. Why do I only have 5 when I'm ending at 6? We started at 2. So typically we start at 1, but not always. So I think this is just to note that just pay attention to your indexing values of things to make sure you're starting where you're supposed to start. Okay, so just add these together. We're going to learn the formula for this later, but for now we're just at 6 numbers, 5 numbers out together. So 5 plus 7 is 12, plus 10 is 22, plus 13, 35. right, next. So this one we're just doing 4 numbers. So we're going to have 52 over 100 to the first power plus 52 over 100 to the second power plus 52 over 100 to the third power plus 52 over 100 to the fourth power. So I probably want to use a calculator to do this and get a decimal. I mean, it should be a nice decimal because it's all base 10.
Yeah, you can simple a decimal right now in the calculator.
Okay. Because isn't this one 0.52? And then this one would be 0.0052, wouldn't it? Because of the 2 zeros, so it would be 2 more decimal places, and then 0.000052, and then 0.00000, I didn't do enough, 52. So our sum's going to end up being 0.52525252. I think. Did anyone check it?
I am not checking. But when it, yeah, that's it, yeah.
Yeah, okay. Woohoo! Alright, the next one is weird because it starts at 0. I don't like the look of that problem. It's ugly.
Yeah.
Alright, we got this. So we're going to have -1 to the 0 plus 1 power over 0 plus 1 times, oh, also we don't have an x value. That means this is going to be an equation because we don't know what x is. All right, so there's the 0 part of that. Let's see. So that's going to be a negative number. -1 over 1 times 1. So that part is just going to be a -1. Okay, and then we have -1 to the 1 plus 1 power. So to the second power, that means it's going to be even. And then 1 plus 1 means it's going to have a 2 on the bottom. And not even, but it's positive. So positive 1/2, because it is even, it's a positive. And then we don't know what x is, so we just have to go with it. X minus 1 to the 1 power. So this would be 1/2 times x minus 2. The next one should be negative because it'll be an odd number, and the number on the bottom will be 1 bigger, so it'll be like -1/3 times x minus 2 squared. And then the last part would be a positive number because it's going to be an even exponent. The number on the bottom is going to increment to 1/4. See how I just kind of started figuring out the pattern instead of plugging it into the formula? Because I've got the pattern. I felt like that was easier. That formula is scary. And then that's to the third. And we're going to clear up to 4. 1, 2, 3, 4. That means we have 5 terms because we started at 0 instead of at 1. So this will be a -1/5. It's an odd exponent. So the 4th power. I do not expect that they would expect us to multiply that out to find the combined answer, because that's ugly enough as it is. You can look at the textbook and see what they think. I don't know. That just helps you understand the process. That's the point of having something ugly like that. It's a process. You plug it in everywhere. You start at one point, you end at another point. If it has a variable in it, it just stays there. Good? Okay, stop that video and process it, and we'll go to the next one.
We haven't learned it.